Oh, okay, now it is. So today is Halloween. So I decided to make our slides very Halloween themed. And some of our questions will actually be Halloween themed as well. So today's going to be a pretty chill class, nothing too hard. But so we're going to do something about the coordinate plane, functions, linear equations, some problems, and a fun activity that may or may not be a Kahoot. And obviously there's homework. But first, we will review last time's homework. So, could you put the link in the chat, Yolanda?
Yep, sure.
You can see the presenter view thing.
Yeah,
Oh,
we can see it.
well, that's weird.
Maybe it's a WebEx thing.
Okay, well, I know I made these, so I think I should be fine without the presenter view. Okay, so I think everybody should be able to edit this. I hope I made the settings like that. Yes. So, you want to explain the first one, Yolanda?
Yeah, sure. So the question asks, what is the length of the line segment labeled X? So you can see that on the circle there. And now for this type of problem, if you remember back to last class, we learned that the pattern, the formula you would use is 6 times 6 plus 8, and then that equals 2 times 2 plus x. All right, hopefully that sounds familiar. And then now we would simply solve this. So this would be 6 times 14, which evaluates to 84, right? And then that equals 2 times 2 plus x. So if we divide both sides by 2, then we get 42 equals 2 plus x. And so we can see that x equals 40. So that would be your answer.
Okay, so the next one,
It doesn't really look like 40.
this one,
Yeah, it doesn't really look like 40.
you're right, it does not look like 40, but it's not drawn to scale. That's probably why.
Okay.
Oh, the second one, yeah, it's really hard to see, but if trapezoid ABCD is inscribed in a circle and side AD is parallel to BC, find the degree measure of angle W. So this one, we have to think back to something we learned a long, long time ago. So does this sound familiar to you? Same side interior angles when we were learning about parallel lines?
Yeah.
Remember? You do remember. Okay, that's good. So we know that angle A and then angle B, they're same side interior because this line and this line are parallel, right? So these two angles, they're supplementary. So this angle is 78. And we learned that opposite angles in a quadrilateral in the circle are also supplementary. So this is also 78. And when we solve for W, we get 102.
Oh wait, all right, so for this final one, it says, if the circle has a diameter 10, solve for y. So I'll just try to make this picture a little bit bigger, if I can. Right. And if you're on it, you should be able to see the numbers. So basically, we're going to focus on the two sort of blue purplish chords. And remembering back to the previous lesson, there was a theorem where when you have two chords running through a circle that intersect each other. So basically what it said is that you can multiply 4 times 3 equals 2 times this missing length right here. So that would be 4 times 3 equals 2 times x. And so 12 equals 2 times x, so x is going to equal 6. And so now we're going to focus back onto the triangle. Oops. We're going to focus back onto the triangle here with the side y. and the diameter, so here. And then we know the length of the diameter is 10, and we know that the longest leg is going to be 2 plus x, or 8. And we know that this is a right triangle because one of its side lengths is the diameter. So using Pythagorean theorem, we know that this side y, is going to be 6, because 6 squared plus 8 squared equals 10 squared.
Any questions? Okay, let's move on back to this. So the first thing we're gonna do is the coordinate plane. So what is it? I think you guys probably have heard of this before, at least, if you don't know what it is. But basically, it's like a two-dimensional, which is like flat space formed by the intersection of a vertical line called the y-axis and a horizontal line called the x-axis. So it's like the little grid thing you see a lot in geometry. And you can graph points on this plane, and you do this by using x and y coordinates. So there's going to be some like points that might look like, well, this is really weird, like this. So this would be the x coordinate, which tells us how far left or right it is. And then there's the y coordinate that shows how far up or down the point is. So we'll see how it works a little more. I have no idea where the eraser is. Oh wait, I found it. This is pretty tedious to erase. Anyways. Uh-oh, what did I do? Oh. Was it? Okay. So graphing points. For x coordinates, if it's negative, then it's on the left side of the origin. And the origin is this little red dot you see in the middle. It's at the point 0, 0. It's like the middle and the basis of this entire plane. And if the x coordinate is positive, then it's on the right side of the origin. So for example, this point would be negative 2, 0. So since it's negative, it's on the left, right here. Positive 3, 0 is right here. And hopefully this should all be pretty familiar to you. So for y coordinates, it's pretty same. So if it's negative, then it's below the origin. If it's positive, it's above. No, that's not what I want. So 0, 1 would be right here. And 0, negative 4 will be all the way down here. There we go. Should I do this? Okay. So this is a very unique looking slanted candy corn that's in the shape of a right triangle. So we're gonna do a little practice. You're gonna find the coordinate points of the vertices, which are these like edge points, I guess, like the pointy ones. And you're gonna find the side lengths and find the area of the candy corn, assuming it's a right angle. And all of these is like, it's by 1 unit, so it's like that. And once you, like while you're doing this, try to think about how the coordinate points and the side lengths were related to each other. So when you get your answer, just like label your answer and then put it in the chat. I'm seeing some good answers.
Are we just doing two side lengths, or do we do the hypotenuse as well?
You can do the hypotenuse if you want. You should probably know it since you did the triangle, but you don't have to. If you find all three, that'd be good though. So I think we can go over it now. Hopefully this would be pretty simple. And if this feels a little like tedious, then, well, today's a very chill class, linear equations. So let's first find the coordinate points. Well, I'm going to do these three things that I pointed out earlier, right? Why is it doing that? Okay. No, I don't want to do that. Okay. So this one right here is 4, 0. This one right here is our origin, 0, 0. Uh-oh. And then this one is 0, 3. Okay, now let's find the side lengths. This one is 4 units long. 1, 2, 3, 4. Notice how the x-coordinate for this one is 4 longer than this. I mean, greater than. And then for this other leg, it's 3 units long. And notice how this 3 is 3 greater than the 0. And this other one, we can use the Pythagorean theorem to find that it's 5. Finally, let's find the area. Well, it's pretty simple since it's just a right triangle, right? So we're just going to multiply 4 times 3, then divide by 2, which gives us 6 units squared. Yay. Any questions? All right. I wish there would be some option that I could clear my entire screen, but
Maybe try clicking the X.
what X?
Is there not an X?
There's a stop annotation.
Try that. I don't know if it gets rid of them next time, but I think I remember it does.
Okay, it does, actually. You're right.
Okay.
Thanks. Okay, let's go to the next one. Oh, so this is a little more practice. This is a nice pumpkin pie. And using your observations from last time, find the area of a pumpkin pie that's in a perfect circle, whose radius starts at the point 2, 2 comma negative 3, and ends at the point 2 comma 5. So when we were doing the triangle, we saw that like the x-coordinates and the y-coordinates, they all had relationships that led to the lengths. So if you can think about it, visualize it in your head, and try to find the area of a circle. Hopefully you should remember the equation.
What do we use for pi?
Oh, you can just leave it in terms of pi.
Okay.
I'm seeing a lot of really good answers. Yeah, so you guys are all right. It is 64 pi because I'm not going to explain it too much since you guys seem to already know it. But these 2 points are like, there are ones above the other one, so they're aligned vertically. And the length of that line is 8, since it's negative 3 and 5. And we know it's pi r squared for the area of, oh my gosh, this is really annoying. Oh no, that's not what I wanted to do. Okay, sorry, I'm confused. There you go. Okay, pi r squared, r is 8, 8 times 8 is 64. So 64 pi. Pi. Okay, let's go to the next part. Oh, we don't need those hints.
All right, so now let's move on to functions. So we're going to imagine that we have a magical candy machine. And into this magical machine, we're going to put in 5 candies, 5 lollipops to start with. So this is called our input. Remember that term. All right, and now after we've put those 5 candies into our magical machine, what do we get? We get out, let's see how many, 9 lollipops. We get 9 lollipops back. So those 9 lollipops are our output. And just as a review, we put 5 lollipops as our input into the machine. We got back an output of 9 lollipops. All right, so that's a good deal. I would love to have a machine like that. And a function is just like a magic machine. So it will take an input and give you back an output. But there's an important rule. So functions can only give one output per input. So say you're putting 1 candy into the magic machine, you can get out 2 candies back. But you can't say, but it's impossible for, say you put in 1 piece of candy, you get either 2 candies or 5 candies. That's too confusing, all right? And that wouldn't be a function because there can only be 1 output per input.
You're trying to say that for 1, it'll always be like 7. And for like 2, it'll always be some different number. And it won't ever change.
It doesn't have to be a different number. It just like if you put in 1 candy, you can only have 1 result. You can't have 2 results for if you only put in 1 piece of candy. But you can put in 1 piece of candy and get out 2 pieces of candy, and you can also put in 2 pieces of candy and still get out 2 pieces of candy. That would still be a function.
Okay.
Good
All right.
question. That's like confusing.
So here's an example. So we're putting in the name of a person as the input, and then their output is going to be their age. Is that a function? Type yes or no in the chat. And you can also explain why, if you want. Think about if there's going to be 1 output for the input, or if there's going to be multiple outputs for the input. All right, so you guys are saying no, but actually I think the answer would be yes, because say we're going to put in the name of a person. Say we're going to put in me, Yolanda, okay? And then their age is outputted. Well, I only have 1 age. I'm 15 years old, okay? And I can't be 15 years old and 16 years old at the same time. So the answer is yes, because there's only 1 output. Yeah, exactly. All right.
Yeah, it's okay that different people can have the same age. So like I'm also 15 and Yolanda's 15, but it's still a function because we separately both have our own age.
Well, what if there are
This is-
many Yolandas in the world?
Oh, well, that is okay. That you're right. If there were different like Yolandas, then that would not be a function. Like if you can't tell like between them. But yeah, I see why you might have felt that. I didn't think about it that much when I wrote this.
That's a good point. Yeah, we should specify like unique names or something.
Yes. Anyways, this is just like how you write a function. You write it with f of x. It's kind of like a y, but that just shows you the output of a function when you put in x.
All right, so let's practice. I gave an unknown number of cookies to a ghost, and the ghost gives me back twice as many cookies as I gave it, plus 4 extra ones. So create a function that models this situation, with x being the original number of cookies that I gave to the ghost. So if you remember on the previous slide, you can use f parenthesis x close parentheses for to represent the output, and then write an equation that models the ghost giving me twice as many cookies as I gave it, plus 4 more.
So could we just make, what would the, so do we have to write like F?
So it doesn't have to be the letter F. I mean, it's very commonly used because F from function. But like if I have multiple different functions, I could have like g of x, I could have z of x.
Okay, I was just wondering if F was like, we had to put it.
You don't have to. It's just like if you only have one function, it's the most commonly used. In a lot of problems, it'll be F.
All right, so you guys are saying 2x plus 4. Which would be correct here? Aniket, yours is basically correct, but you could just simplify it down a bit so you don't have to write the parentheses. So yeah, the function would be f of x equals 2x plus 4. So say I gave the ghost 3 cookies, how many cookies would I get back? Type your answer in the chat.
How many did you give it?
3.
Yeah, that would be correct. So you get 10 cookies back because that would be 2 times 3 plus 4.
Yep. Okay. So writing this leads us to linear equations. Okay, so linear equations are almost the same as what we just wrote, but instead of the f of x, we have a y. And the difference between them, it might be a little hard to see, but equations are just two things set equal to each other. So for example, if I had like 3y equals x, that would still be an equation. I can just say this is equal to this. But a function, you have to have f of x, which is kind of the same thing as a y, just on one side, and it's going to be a system of inputs and outputs. But you treat them basically the same way. So the first form that you see a lot would be this form, the slope-intercept form. And this is especially helpful when you graph. So the m, y equals mx plus b, the m in there is the slope. We'll talk about what all of these are in a second. And the b is the y-intercept, and it only shows you the y-coordinate. There's also other forms that I bet you will learn if you haven't already in school, and there's one of them is the point slope form. There's probably a bunch more, but this one is helpful when you have one point and the slope. So this is just one y coordinate of 0.1, x coordinate of 0.1. That should be 1. And the m is always the slope. So when graphed, linear equations look like this. We should take a second to appreciate all of the hard work I put into making this side really nice. So get ready.
Woo! Great job, Kayang.
Thank you. So yeah, when you graph linear equations, you get lines.
Okay, so now we're going to talk about slope. Slope basically just means how steep a line is, and it's calculated by doing the change in y divided by the change in x over a period. So you can also call this rise over run. Since y is up or down, x is kind of left or right. So just remember, slope is vertical change over horizontal change. And we're going to take a look at what changing the slope of a line does to how it looks.
Right. So I guess I can do it since like I have to show this. But basically, we're gonna look at these two lines. So one is in the form y equals ax, the other one is y equals bx plus 9. So I just put that 9 in there for you to see some other like types of lines. And basically, as I change this slider, you should look at how the number, especially like if it's if it's positive or 0 or negative, how that changes what the line looks like. So let's do the first orange one. Okay, right now it's at 0, and it's the flat one that's on the x-axis. Now I'm gonna go positive a little more. Okay, now I'm gonna go negative from the 0. Okay, so as you see this, you can write down in the chat what you see. I'm gonna do the same thing for this other one, and your observation should be basically the same. So this one is up here, but as I go positive, it goes that way. Negative, woo. Okay. So somebody tell me, you can type it in the chat or tell me just like out loud, unmute and tell me what you saw, how this slope changes.
What
So when you
number?
move positive, it kind of turned to the right, but when
Yes.
you turned it negatively, it moved to the left, which is just another way of showing us that right way is the right way.
Wait, what is the number on the left side of the screen? Like, representing? Like, what is it for? Like, what is it showing? I guess.
The A and the B?
Yeah.
Okay,
Yeah.
so they're both slopes. So I could have used M instead, but this is the slope. We're looking at how the slope changes it. And I said slope is how steep a line is, right? So
What unit of measurement would you use for slope? Would you just use a number?
it's just a number.
And yeah, you said as the slope increases to like a bigger number, it gets kind of steeper and steeper. So yeah, that's exactly right.
If it's positive, then it's steep like. It's if you look from left to right, it's going up. And then if it's negative, looking from left to right, it's going down. Okay, so good observations, guys. Let's move on. Okay, the next thing we're going to talk about is intercepts. So there's two different types of intercepts that you can see on the right. There's the x-intercept, and that's where the line intersects the x-axis. Remember, the x-axis is the horizontal one, right? And then it's in the form x comma 0. So right now, the one in the picture would be like -3 comma 0. And the y-intercept is where the line intersects the y-axis. So it's here. And it's in the form 0 comma y. So if you remember from a couple slides ago where we had those two big forms on the slide, the y-intercept is in the linear equation, y equals mx plus b. The b, oops, I don't want to go that far. The b right here would be the y-coordinate of the y-intercept. All right, so a practice combining both slope and the y-intercept. Tell me what the slope and the y-intercept of these following lines are. The blue one, I mean not the blue, I think that's purple. Purple one and the green one. Remember, slope is rise over run, which is the same thing as change in y over change in x. And the y-intercept is where the line touches the x-axis. So once you get your answer, just put it in the chat and we'll check it.
I'm confused. What is the formula for it?
For the slope?
Yeah.
Okay, so the slope formula. So let's see it in action. Let's do this purple one together, and you can do the green one on your own. So slope was, what did I say it was? It can be said in many different ways, but one would be, let's go with change in y over change in x. Change, I'm just gonna shorthand it, change y, change, oh no, don't do that, change x. So what do I mean by that? Well, when I do slope, I'm gonna find 2 points that are easy to use. So what I mean is, let's say I try to use this point right here. That is on the line, right? Like it's like I could use it, but it's gonna be hard for me to tell like what the exact point is. I know this is -1, but how far, what is this one? Like I don't know where that's supposed to be, and I don't know what just happened. It could be like 1 and 1/4, -1 and 1/4, but it could be -1 and 1/3. Like you don't know for sure. So it's easier to use a point that's directly on the graph, like this one. I know that this is -2, comma, -1.5. Or I could use an even simpler one. I could use this one. -4, comma, -1. How simple? No decimals. Okay, so this is going to be my first point. Now I'm going to use another one. Let's use this one. Pretty simple, right? It's right on here. 0, comma, -2. Now I'm going to do change in y over change in x. So the y coordinates are these, right? Do you have a question? I think it's
Yes.
a call.
So does do the points you use can the points be anywhere on the line, or do they have to be like the the same distance like from where they intersect on the y or x axis?
No, so it can be any 2 points on the line. It could be like, I don't know, this one and this one. As long as they're on the line, the distance between them doesn't matter, but it's just easy to use ones where I know the coordinate exactly.
Can they be like on like one side of the x-axis or like one side of the y-axis? Like, is there any specifics, or like absolutely any 2 points on the line?
It's just absolutely any 2 points. Because if I like use like these 2 points, for example, then if I just cut this segment like this much, that's still gonna be the same slope. The slope is how steep the line is, right? So that's not gonna change no matter how big or small of a portion I look. Okay, great question. That's a good question. Anyways, so moving on. -1 and -2. These are my y coordinates. So the change between them, I have to subtract one from the other. But I have to make sure that if I subtracted -1 from -2, then I subtracted the first one from the second one, right? I have to remember that. So I'm going to subtract -1 from -2. So -2 minus -1 is -1. Okay, fair enough. That goes at the top of my fraction. The second thing I have to do is find the change in x. So these are my x. And remember, I subtracted the first one from the second one, right? I can't forget about that. If I switch that around, then it's not going to work. So subtract the first one from the second one. So 0 minus -4 is 4. So now the bottom is 4. So this simplifies to -1/4. -1/4 is our slope for this line. And if I looked at the rise and run method, I could do, let's see, I could do these 2 points, this one and this one. This might be hard to see, but I went down 1, that's my rise, -1, and I went right 4. So it's -1. Okay, does that make sense? So if you guys could do the y-intercept for the first one, actually, I'll just tell you that one. It's right here.
I'm sorry, but what were you guys talking about? I had to go to the bathroom and my thing died, so I was kicked out.
Oh no. Okay. Wait, who's talking? Is it? Oh, okay, yeah. Do you understand how to do slope?
Think it was raise over rise.
Okay, you're kind of close, but so everybody else, you can move on to the green line. I'm just gonna re-explain this one, but if you didn't get it, you're welcome to look at it again. So slope is rise over run. You're almost there. Rise means when you think of rise, like you don't rise sideways, right? You like rise up, right? So that's up and down, which is Y. And then run is you don't run like up in the air. You run left to right, right? You run on flat ground. So that's run. So that's X. Yeah, do you have a question?
When you're figuring out the slope of the purple line, how
Mhm.
did you get 0 and -4?
0? Oh, okay. So that's just my like points. So I think I used this one and this one, right? Yes. Okay, so I picked 2 points that are easy to see on the graph. So I'm gonna pick this one and this one. So remember we just did naming coordinate points, right? Do you know how to name these 2 points? What would it be?
Me?
Anybody?
0, -2,
That's one of them.
and
What's the other one?
-4, -1.
Yep, exactly. So that's where I got my 0 and -4 and that stuff from. Okay, so now I'm gonna do rise over run. So this is a more simple one when you can actually see the graph. So rise was up and down, right?
Yes.
Run is left and right.
Mm-hmm.
So the rise, the difference in the up and down between these 2 points is this distance, right? And this is 1.
So the distance between the point you mark, one of the points, to the difference in the x and the y coordinate between the one point and the other.
Yeah,
Okay.
yeah. So I could do -2 minus -1, that's -1. Over, now I'm going to do run. Run is the difference between the x coordinates. And that's what? 1, 2, 3, 4. So I put 4 at the bottom. And that's just gonna be my slope. But one thing you have to make sure is, so technically I could do 0 minus, no, not 0. -2 minus the -1 over 0 minus -4. Or I could do -1 minus -2 over -4 minus 0. It doesn't matter what order I put it in, but I have to make sure, like I could do either of the 2 options I said, but they have to be in the same order. So if I subtract 0.1 from 0.2, then I have to do that for both coordinates.
Okay.
Okay, did anybody figure out the green one? If not, we should just go through it together.
Is it like 0/4?
0/4.
I put my answer in the chat.
Who was that? Was that Colin?
Yeah.
Okay. The green line. Okay, and so you were like pretty close, but you found the x-intercept. So the y-intercept is the one on the vertical line. So that'd be 0, 6.
Oh. Oh.
And then the slope, let's do this one together. So I'm gonna clear this thing. Now let's do slope.
If we were solving for x-intercept, would that be correct?
You'd be correct if you were solving for x.
Okay.
Okay, so let's do both rise over run and one where you use the coordinates. So let's see. I could pick a lot of these points. A lot of them are on a good spot, but I'm gonna use this one. I know that's -3, comma 0, and let's use we could use this one. This one is -1, comma, we're at 4, so it's -1, 4. Now, let's first do rise over run. So when I do rise over run, I have to start at 1 point only. So I'm going to start at this point. So in order to get to my other point, I have to go up, right? So that's up this much, and that's 4. So I went up 4. That's positive. Then I also have to go, this isn't where the point is, right? I also have to move right a little bit. I have to move right 2. That's also positive. Moving right is positive. So now, +4 over 2 is 2 as my slope. Now I'm going to do it with the coordinate points. So we should get 2 as our answer, right? We already checked it on the graph, but let's do it this way. So first we have to do, remember we can't put the x on top. We have to put the y's on top. So change in y over x. That's how you write it, shorthand. So 4 minus 0 is 4. -1 minus -3, that's 2. Wait, we've seen this before. That's what we got when we used the graph, right? That's also 2. So the slope of this is 2. Does that make sense? Is this confusing? Should we do another one?
2 what?
Hmm?
2 what? Like 2 feet? 2 inches?
So slope actually doesn't have a unit. It's just a number. Slope is how steep a line is, and for some reason, math people just decided not to use units. It's just 2.
Yeah, so it just represents for you
Math
move
people
one
are too cool for units on slopes.
So it's basically like say you move 1 unit right on x, you're going to move 2 units up on y. Rise over run, so that's why it would just the slope would be 2.
Yeah. And
Okay.
we already said the y-intercept is this one where the line touches the y-axis. That's 0, 6. And I'm pretty sure there's gonna be more problems that are like practiced later on, so we're gonna go through those. So, and obviously slope and like functions, they're all really, really big topics. And if you don't completely understand right now, that's okay. You'll definitely learn it at school. Probably, I want to say maybe 6th and 7th grade. I think you should learn it all by 7th grade. So it makes sense that you don't know it right now. That's perfectly fine.
All right. So we're going to cover how you can figure out if 2 lines are parallel or perpendicular just using their equation. So we're going to start with parallel lines. And as a review, parallel means that 2 lines have no points of intersection with each other, no matter how far they go. So if 2 lines are parallel, they're never going to cross. And parallel lines have equal slopes. This makes sense, right? Because say a line is sloped this much, a parallel line would have the same slope, and that's why they would never meet. So for an example, the line y equals 1/2 x plus 5 would be parallel to the line y equals 1/2 x minus 4, because remembering the form y equals mx plus b, the number in front of x is the slope, and so both of these lines have a slope of 1/2. And okay, so just for practice, I'm going to think of a line. Let's say y equals 3x plus 2. Type in the chat a line that is parallel to y equals 3x plus 2. That isn't the same line.
So just a hint, the only thing that has to be the same is the slope. Ooh, somebody got a good answer.
Yeah,
But
y
you can
equals
change the
3x.
number after it.
Yeah, excellent. So that would just mean the y-intercept changes. So your line is just a little bit above mine on the graph. All right, does anyone else want to share an answer?
So as long as you keep the 3x, you can change the last number. It could be like negative 1 million.
All right, y equals 3x plus 4 minus 2. If you simplify, so technically, yeah, but if you simplify that down, you get y equals 3x plus 2, which is the same as my line. Yeah, very funny. All right, so we have 3x plus 10. Now, don't forget the y equals in front of that. That's pretty important because you have to have like the y coordinate of it. But yeah, 3x plus 10 would be a great example. Y equals 3x plus 10 would be a great example. Okay, so let's move on to perpendicular lines. So perpendicular means that the two lines intersect at a 90-degree angle. And perpendicular lines have a slope that is an opposite reciprocal. So opposite reciprocal, what does this mean? Well, opposite just basically means the sign changes. Sorry, the sign changes. So a positive number will become a negative number. And reciprocal means that you divide something by 1. So say we have the number 2 as our slope for a line. We're going to find the opposite reciprocal of 2. So first we make 2 negative, that would be doing the opposite, and then we find the reciprocal. So the reciprocal of negative 2 is going to be negative 1/2, because you're just doing 1 divided by negative 2. And another way to think of this is just divide negative 1 by the slope to find the opposite reciprocal. Okay, so for an example, the line y equals 2/5 x plus 2 is perpendicular to the line y equals negative 5/2 x plus 10, because 2/5 and negative 5/2 are opposite reciprocals. So let's do another example. Say I have the line y equals 1/3 x plus 5. Type in the chat a line that's perpendicular to that. Remember,
What was the line again? I didn't quite catch that.
I typed it in the chat, but it's y equals 1/3 x plus 5. And apparently Colin has some candy, but he's not sharing.
Grab it from your camera? How is that
I
possible?
already ate it. I already ate it.
Well,
So
that's
rude.
not nice.
All right,
I can get a full one.
All right, you said y equals 1/3 x plus, is that 1 million? Sorry, I can't count zeros.
That's 100,000.5.
Yeah. So that would actually be a parallel line, because remember, perpendicular would be opposite reciprocals of the slope. So let's see. Yeah, so y equals negative 3 over 1. Negative 3 over 1 simplifies to negative 3. So you said y equals negative 3x plus 10. That's a great example. So negative 3 is the opposite reciprocal of 1/3. Great job. Okay, Anushka, yeah, your answer is correct. You can remember, simplify negative 3 over 1 to just negative 3. Colin, you said 3 over 1x. Well, you did the reciprocal part correctly, but it's not the opposite sign. So if you said y equals negative 3x plus 20, that'd be correct. And yeah, there are lots of lines that are perpendicular to the one I said.
There's actually an infinite number, so.
Okay. So does anyone have questions about finding either of these? Yeah, Aniket, that's perfect.
Okay, so we can go on now to solving linear equations. So who knows how to solve a linear equation? It's gonna be something like 0 equals 2x plus 1. So you have to solve for x.
Me.
Yeah, you do? Okay. So I have a feeling that some of you might already know how to do this, but this is very, very important and it's always good to review a little. So this won't be too in-depth, but hopefully this should be pretty familiar. So in order to solve a linear equation, what you do is you try to isolate the variable and you add like terms. But what if
Before
you
we
do
move on, I have a question.
Mm-hmm.
So, like, you know how you showed for perpendicular how 1/3 becomes -3?
Yes.
What if it was like 2/4?
Okay, so 2/4. So what you do, like if it's hard to think about negative reciprocals, I think the easiest way would be you have -1 at the top and your number at the bottom. So right now you said, what was it? 2/4?
Yeah.
Okay, now I'm gonna simplify this fraction. So actually, if you don't know how to simplify a fraction like this, then this might be harder. But if you
That's
do,
half, right? It's 1
yeah,
over 2.
this is the same thing as 1/2. Yeah, but if you do know how to simplify this, then this would become -1 times 2, which is -2. Or you can do it this way. 1/2. So I'm going to find the reciprocal. I switch the top and the bottom. That becomes 2. But now I have to put a negative sign in front of it. So that becomes -2.
Okay.
So
So
does that help?
Yeah, flip the fraction and change the sign, right?
Yep, exactly.
Okay, thank you.
Yeah. Okay,
Your
so
candy shower, Colin.
he's giving us a candy shower. Have you already gone trick-or-treating? It's today.
Yeah.
Anyways, so whatever you do to one side, you have to do the other. Okay, so I'm going to do this. Basically, I'm going to try to solve for this x. To do that, first, before like multiplying and dividing, subtracting or adding is the better option. It makes our equation less messy and easier to handle, and nobody likes messy equations. So I'm going to subtract 14 from each side, since I want my x to be just on one side of this equal sign. And whatever I do to one side, I have to do the other. So 6 minus 14, that becomes -8. And now I just have my lonely 2x over here. Now, to get this x only, I have to divide by 2 so that the 2 is gone. And whatever I do to one side, I have to do to the other. So the 2's cancel out. And I'm left with x equals -4. I think this might not be the best color. X equals -4. So any questions about this?
I think another way to think about it is like, what number times 2 will plus 14 would equal 6?
Yep, that's exactly right.
And since 14 is bigger than 6, it has to be a negative number.
Yep, yeah, that's pretty smart. Yeah, you're right. Okay. So you don't understand. Have you learned this at school or no?
No.
Sorry, I
Are
covered
you-
my keyboard in candy and the random keys accidentally X'd out the tab.
Okay, are you in 5th grade? or fourth, maybe?
No, I'm in 6th.
I'm in 6th grade.
No, not you guys. The person who told me they don't understand. Rishi, Kat?
6th.
Wait, 6th grade?
Yes.
Okay. So if that, yeah, it's possible that you haven't learned it at school. So you will learn it at school eventually. But so this might be like hard to learn all at once because it's
I
just a
mean, like,
really subject.
I do get it, but can you go like through like it again?
Oh, okay, yeah, I'll do it again. So, okay, basically, before multiplying or dividing, I'm gonna do the most subtracting and adding as possible. So right now, in order to get this x to be alone, I have to move this 14 over and move this 2 over. But in order to get rid of the 2, I have to divide. But for the 14, I can just subtract. So I'm going to make the 14 move first. So I'm subtracting 14 from each side. I have to do the same thing to both sides. That's just a really important rule. So 6 minus 14 is negative 8. And this is gone. I just have 2x now. But my x still isn't alone. There's this annoying 2 in front of it. So in order to move the 2 to this side, I'm going to divide both sides by 2. So these 2's cancel out, yay! And negative 8 over 2 is the same thing as negative 4. And finally, my x is by itself, so I know that x equals negative 4. Does it make more sense now?
Yes. Yeah.
Okay, that's wonderful. Yeah. And thank you guys for asking questions. This is like really, really good. Like if you don't understand, you have to speak up, okay? So now we're going on to practice problems. And we're not going to do all of them because, wait, do you guys like Kahoots? I don't really know you guys. Do you like Kahoots?
What kind of question is that? Of course we like Kahoots.
Okay, that's good. That's wonderful. My other class was like crazy for Kahoots. So we're going to do this Jamboard, but we aren't going to do all of it because we want to do our Kahoots. Kahoots are more fun than Jamboards. I think everybody will agree with that. So,
I'll put the link in the chat.
oh, I have no idea why this one is here twice. It's not supposed to be, but it's okay. Let's see. I'm gonna do this one, and we'll do like 2 more. So I'm gonna do that. This one, I like this, and we'll do this one. Then we'll do all the Halloween pictured ones, cause yay, they're fun.
Right. So go to slide 3, everyone. And
you want to do this, Yolanda?
yeah, sure. So the question says, when the American Idol competition was down to the final 2 contestants, the winner was ahead of the second place finisher by 12 million votes. If the total number of votes was 90 million, how many votes did the winner get?
By the way, these are the 2 final contestants. Who do you think is the winner? I think the left one should have won
Definitely.
because the right one just is too mean looking.
Do we just add post-it notes?
Yeah, you can add post-it notes with your answer.
And you can also write the equation you used.
I've made a mouse pad of candy. Look.
That doesn't seem very...
Seriously, dude, where did you get all that candy?
I went to like a Halloween thing for my swim club, and I literally got like every single one of piece of that candy from there.
Oh my goodness, that's
Dude,
a
I thought you
lot.
already. Dude, I thought you either won the costume contest and somehow I didn't know when you got all that candy. Because I saw somebody else's bucket of candy who got like second and third place and they were like big. But no, you just went to a swim thing and just mugged the candy store. Okay. Okay.
We will play Kahoot very soon.
All right, so guys, think about your answer a little bit. So say, if we do have one person getting 57 million votes, then how many votes is the other person going to get? That's going to be 90 minus 57, which is 33. So actually, one person has 24 more votes than the other person. So that can't be possible. I mean, sorry, 24 million more votes.
Oh no, I just saw the right answer go away. Somebody had it.
Yeah, you had it. Okay. Okay, you're changing yours to 51. All right,
You're right.
so in the interest of time, I'll go ahead and explain why the answer is 51. So for this problem, we should try to set up a linear equation since that's what this class is all about. So we'll do, okay, wait, sorry. So we'll do 90 million equals, and now we're going to say the second place finisher is going to be X. And then, so the total number of votes, 90 million, is going to be X, which is the second place finisher, plus X plus 12 million, which is going to be the first place finisher. So that, if you add it together, is going to be 2X plus 12 million, right? Sorry, 12 million. Okay, and then now we're going to try to isolate the variable on one side. So we're going to subtract 12 million from both sides. Whatever you do to one side, you have to do to the other side. And so then that gets you 88 million equals 2x. And if you, sorry, if you divide both sides, sorry, 78 million. I was like, what's going on? 78 million equals 2x. And if you divide both sides by 2, then you get 39 million equals x. So remember, x is what the second place finisher got. And we have to add 12 to that to figure out how many votes the winner got, which is going to be 51 million, like you guys are all putting now. So good job if you got that.
Okay, so I think we should do just one more problem and go to the Kahoot. Because we actually have more than one Kahoot today, so they're both short, but we have two. So let's do this one. I'll do it. The vertex.
My Jamboard is not working.
Your Jamboard isn't working? Oh no.
Oh, never mind. Never mind. It was just lag. Oh shoot! It was just lag.
God.
There goes the candy basket.
Oh no. Okay.
That's some fired a gunshot just now. I was watching Squid Games earlier, so I was like,
How's
well,
my candy basket falling?
no, but it was just calling Candy Basket taking a dip.
Yup. Okay, back to the question. The vertices of a door in a haunted house are at 2, 3, 2, 6, 6, 3, 6, 6. Find the area of the rectangle. So
I've been doing so many of these problems on Khan Academy. It is pissing me off, and now it's actually getting useful.
Okay, let's see if you can get it right then.
Yeah, I already know what the answer is.
You do?
Mm-hmm.
Okay. I see one right answer. So I'm guessing that might be you.
No, I'm doing it in blue.
Oh, okay. Did you know that Epic doesn't have a K?
Who doesn't have a kid?
Epic just has a C.
Oh.
Now you got it.
Ooh, okay, you're right. It is 12. So, our epic door, I'm going to use this epic door drawing. Thank you for drawing this. All right, so one of the points is at 2, 3. So, this is going to be this one. 2, 3. One's at 2, 6. That's the one that's the same amount, right? But it's above it. Now, this one is the one that's like highest up all the way to the right. 6, 6. This one has to be then 6, 3. Now, to find the rectangle, I have just to find the side length of this and this. Length times width is the area. So the width first, the 6's are the same, but the 2 and the 6, that's a 4-unit difference. The 2's are the same, the 6 and the 3 are a 3-unit difference. 3 times 4 is 12. You made the epic door? The epic door. Nice. Alright, let's go.
What epic door? I'm confused.
It's a door on the Jamboard. The drawing.
But
It's the epic door.
but why a door?
I don't know. It's a
Who knows?
rectangle. Anyways, alright.
Kahoot time.
First do the first Kahoot.
Okay, first Kahoot.
This is. Uh-oh. Continue.
I'm going to do something unheard of. I'm
Huh?
kind of confused, so I don't want to do the Kahoot.
Why did this happen? It's
I don't
this-
want to do the Kahoot, and I'm super confused, so I'm just going to sit here and watch you guys solve Kahoot.
Oh, you should still try.
Meaning, like, I have no idea.
Never know if
like,
you don't try.
It's fine.
Let's
Because,
do this.
it's fine because then I can ridicule Colin by saying I can ridicule Colin on his place when we get back to school on Monday.
My sister and my sister's friend is right here right now, and they're talking like crazy.
That's okay.
Colin, maybe we should get together sometime so we could talk our heads off.
If you notice, this song is Kahoot Halloween style. Interesting. How many people are in here right now? 1, 2, 3, 4, 5, 6, 7, 8. Maybe like 9? Can't really tell. But
Does anyone care for a Hershey's bar? How about two?
get it.
My dad said
How about three?
Walmart got ransacked when he went to go get candy a little while
How
ago.
about 5?
There's
How about
no
6?
candy. No, nothing.
How about 7? How about 8?
Colin, are you becoming a bidding
How about
man? Colin, are you becoming a bidding man?
I'll take it.
How about 11?
I'll take the whole stack of it.
Yep.
Guys, pay attention. It's starting.
Okay, now shut up. Math time.
They're all in this format: parallel, perpendicular, or neither. I think you
What
guys got-
happened to the numbers? The numbers are glitchy.
They are. Uh-oh.
Yeah, they were like very glitchy. And why is there just a big H?
I don't know.
Just why a big H?
The H is a very helpful visual representation.
Yes,
You'll
maybe.
see. You'll see.
I
You'll
think
see.
I know the answer to this. I'm just gonna like remembering formulas.
Yay!
Follow
Parallel.
the- Who said neither?
Me,
That's
don't judge my skill.
Colin, why did you say neither?
You can still join if you
The
didn't
basis
join.
of bad decisions.
It doesn't look parallel.
What? Yes,
There's
it
no
does.
visual representation. How will you know if it? How will you know if it works parallel?
Because remember, we look at the slope. The slopes are the same, which
I
means.
remember this. Also, my
Ooh,
friends are texting me on when to meet up for Halloween. I'm just gonna go walk with them
nice.
because
Ooh.
I need to learn how to walk.
What's this?
Oh, I see what you're doing now.
What am I doing?
You are spelling out Halloween, so there's gonna be Hallowe'en. There's gonna be only 9 questions.
You'll see.
9 questions,
We'll see
and maybe
about
the last, maybe a 10th one.
Well, you can see there's only 5 questions. Sorry to burst your bubble.
My bubble.
Yay! They're opposite reciprocals. Yep, they're perpendicular. The slopes are opposite reciprocals.
Wait, why
Parallel
exactly?
this time.
Why?
It's Halloween.
Look at my stack of Hershey's.
Oh my
Colin,
goodness.
stop being a bidding man.
Ah, no, they fall. No.
It's glitching, so all I can hear is doop doop. Wait, HAP. What does HAP spell?
What does it spell?
I wonder.
Happy?
Happy.
Is it happy?
The last question will be why Halloween.
And the next question will be a P.
We'll see.
I have
Pay
baseball
attention
bad
to the
decisions
signs on
ready.
this. Yay, everyone's doing well. Yeah, it's neither.
I've
Fair
got
enough.
none right. What do you mean?
Baseball bad decisions.
Maybe your candy is distracting you, Colin.
Maybe your
I'm not even
candy's
I'm not
putting
even
so much
looking at the
sugar high
question.
in your
I'm
brain
just
that so
randomly
much
choosing
sugar
any
needs to
one.
process.
I'm not even looking.
Yep, I knew it. One more P.
It could be anything. The happy.
There is only one. Okay,
Whistling.
I'm gonna go to Google and search up HAPP.
Oh my gosh, almost everyone got this. Yes, the same.
See, everything says happy.
Okay.
HAPPP.
No, HAPP.
Whatever. We'll
HAPP,
see.
Colin. Papa. I like to torment the kid. Using the very little Hindi I know, I like to torment the kids at school by saying things.
Using the vast knowledge of Chinese, no, I like to torment Anushka. 你觉得这不好给你吗？你觉得呢？ 你饭桶。哎，你觉得呢？
Annie.
Does anyone here know Chinese?
Yes, but I can't understand you.
Yes.
Perpendicular boy.
你现在知道我在说啥呢？
我知道, but
Huh?
this is a math class, so we should focus. This
Okay,
is not
so
There's no way I'm winning. Yeah, there's no way I won.
Halloween one.
Wait, I didn't. Wait, what's
Horse-
the answer? What was the answer to the last one? I wasn't
Wait a
listening.
minute. That's why they did that. They spelled out happy. One of these two named themselves Halloween, took the Kahoot, got first place, and it
Who
spells
was
out
it?
Happy Halloween.
You're
Who was it?
exactly what we did. Good job. You figured it out.
You guys are detectives.
I figured
Wait,
it
what's
out
the
because
answer to the last question? I didn't get to see
This
it.
is why I scored a 24 on the
that's
COGAT test and when I was in third grade.
I think.
Wait, what was the answer to the last question? Was it neither parallel or
I
intersection?
think it was perpendicular.
Oh, I got one right then. That's nice.
Good job. Okay, now let's go to the other Kahoot.
All right.
What other Kahoot? There is
What?
another
There's
Kahoot?
another Kahoot. Don't you like going? I thought you said you like Kahoots.
I like Kahoot, but I like it when my Kahoots are together. I think my brother last year for a language arts assignment. Who's playing Rick Ashley? Baseball bat, a bad
Not
decision.
me.
Colin, I can see your thing light up when you're not talking. Turn Rick Ashley off, or the baseball bat, a bad decision will haunt you forever. No. Say goodbye. I think somebody rickrolled YouTube once.
Wait, is there a second Kahoot?
Who named themselves, you know the rules.
I'm gonna mute you.
My neighbors are texting me, when do you all want to meet up for Halloween?
Stop rickrolling us. Bye.
For
And
so long.
what the heck? My brother sent everybody the picture of Reese's. Why did you send a picture of Reese's? Random picture. Oh my god.
Okay, both of these are actually right because you can do it either way. Just a change in y over change in x. I think this is really short too. Yeah, there's 8 questions. Is it linear or non-linear? Remember, linears are just one straight line. That should be a very good clue. Yay, good job, guys.
Wait, if you get first place for both, does that mean you get the points for both?
Yep.
Mhm.
Okay, this might be kind of hard to see, but hopefully you can still see it. This might not be the best
I
question.
can barely see that.
Yeah. Just guess at this point.
Yeah, I guessed. Yay, I got it right. Nice. Let's go.
Imagine guessing on a Kahoot, but imagine not playing it to learn more. Who just put pumpkin emoji? And if so, how did you get that?
Anything to learn though.
Okay, I skipped this too because you can't see it.
Yes,
Or
cool.
you better get this right, okay? One output per input.
Can I just say this?
You can
Yes.
say yes. You might be right.
Yes,
I
to
just
every
wanna
extent
say
it is true.
that I'm never gonna give you up. I'm never gonna let you down, and I'm never gonna run around or desert you.
Thanks,
Shut up, Colin.
I'm never gonna make you cry. I'm never gonna say goodbye. I'm never gonna tell a lie or hurt you.
Shut up. Dude, nobody wants to hear you speak. Reek Ashley. Reek Ashley. Yes, Reek Ashley.
Next person to rickroll anyone loses 10 points.
Colin, think twice before you rickroll.
Uh-oh. Okay, this was just like you use two of these points and you do change in y. If I use the first two, it'd be 6 over change in x over 2. So that gives me 3 as my, and you can figure it out just with this look.
Watch me
Can I stick
grow.
another
Now
coconut
watch
ball, you guys? Then, if I can't rickroll.
What? No, nothing off topic.
Okay. So does anybody else want to go off topic?
How about let's do it. Wait, the question still hasn't loaded in for the me. It's so it still hasn't.
Yes.
Really?
I'm experiencing.
Oh my gosh!
No, it's finally up.
Finally,
Yeah, it
loaded
didn't load
in.
in for me
There
too. I
was
was
1
waiting there
second
and
left
staring
on
at
the
a
timer.
That's not good. Dang, this might be kind of hard to do in 30 seconds.
Yes.
Okay,
Yes.
this is your Halloween present. I'm gonna do this and then tell you what it is. Okay.
Hurry up, we only got 10 seconds left.
It's the yellow one.
Yellow.
It should be.
Wait a minute.
If you make it wrong,
It's the yellow
Like-
one. I promise you. See, you should have trusted me. Yes, actually,
Everybody did trust you.
yeah,
I can see nobody
everybody
picked
did.
Let's see how we did, everyone.
red, blue, and or green.
the rules. Who's that? We need to
Colin.
get
And so do I.
Good job. everybody.
and
Colin.
pumpkin one.
Who's pumpkin?
I don't
Who
know
might
who is
wonder who
pumpkin.
Pumpkin is. If Pumpkin
See, the first to point the finger is the one who has
if
something linger.
Pumpkin doesn't
Guys, am I
say who
runner-up?
they are, they're not going to get any points. Wait, who's you know the rules?
Colin, I think.
Okay.
Wait, no,
No. No, I was a runner-up. I was 5th.
who is you know the rules?
Oh, that's me,
Who's me? Say your name.
Sid.
Okay.
Okay.
You will get points then. All right. I guess Pumpkin will not get any
Alright.
points because they have.
Bye, everyone. Happy Halloween.
Yep, happy Halloween. There's
Happy
homework, don't
Halloween.
forget. But you don't have to do it today. Just do it during the week. Or do it like
Bye.
next Saturday. Bye guys. Have
Bye,
fun
everyone.
trick-or-treating if you are. If not, enjoy your Halloween.
Don't eat too much.
Bye. Happy Halloween.
Bye. Thank you. You too.